Question number 20. We are given two batteries, 6 volt. In one case they are connected and they have an internal resistance 1 ohm. In one case they are connected in series, and in other case they are connected in parallel. And then we connect an external resistance R, and we are trying to find out the current flowing in that resistance in this condition number 1 versus condition number 2 for three different values of resistance: 1 ohm, 0.1 ohm, 1 ohm and 10 ohm. What we will do is we will try to find the current flowing in this circuit as a function of R and current flowing in this circuit as a function of R, and then we will try to find the ratio. So this should be an easy problem for this one. You have a 6 volt battery, Both of these batteries will try to send the current in this direction, and hence it's easy to apply the Kirchhoff law, which will say that this current I is given by 6 volt plus 6 volt divided by all these resistors here. R plus 1 ohm plus 1 ohm equal to 2 plus R. The total battery is 6 plus 6 equal to 12 divided by 2 plus R. You could also write this Kirchhoff voltage law equation something like this. 6 volt is trying to send a current. This 6 volt trying to send the current. So it's 12 is equal to this current I1 multiplied by R. It is the drop across this resistor plus this same I1. We call it I1 into 1 ohm plus I1 into 1 ohm. Whether you do it by this way, the Kirchhoff law, or you can directly write it. We have I1 is equal to 12 divided by 2 plus R. We could go ahead and find out the value of I for different values of the resistor 0.1, 1 and 10 ohm if required. But this is not a good method for this particular solution because it's redundant. Let's try to find the current as a function of R in this circuit and use the division. Now in this circuit, we need to find this I2 current flowing in R, and for this we use some tricks. In all problems, we're trying to find the trick. Simplification reduces a lot of your time. So if the current I is flowing from this battery and the current I is flowing from this battery, then these two currents join to form, if this is Ix, this is Iy, then this current here will be Ix plus Iy. But we know that this one is very symmetrical to exactly same as this one. These two circuits are symmetrical. They are connected to an external resistance in exactly the same way. So the current that is flowing from this one will be exactly same as the current flowing from this one. Okay. So if the current is flowing from here is I, the current flowing from here will be I, and the total current will be 2I. This is the kind of the symmetry that you must exploit. And now the current flowing in this one is 2I. We can apply the Kirchhoff voltage law in this loop. In this loop, the battery is 6 volt supplying current to this resistor and this resistor. So we write 6 volt on the right hand side. On the left hand side, we have all the voltage drops across the resistors. This is 2I into R and plus I into R. I into R is 1 ohm, so it is I into 1. Now we need to solve this equation for 2I, which will be the same as I2. So to solve this for 2I, we multiply this whole equation by 2I. So we have 2I here and 2I into 2 here. So and this one becomes 12. So 6 into 2 is 12 divided by 2R plus 1 here. So the whole equation becomes 2I equal to 12 divided by 2R plus 1. And this we call as I2. Now we need to find out the ratio of I1 and I2. We could also solve this for I equal to 0.1, 1 and 10 ohm and then find the ratio, but it's better to just take the ratio of I1 to I2, which is I1 is 12 divided by 2 plus R, I2 is 12 divided by 2R plus 1. So the I1 by I2 ratio will be 2R plus 1 divided by 2 plus R. Now we can solve this for call it K, this ratio K, I1 divided by I2. For R equal to 0.1, it will be 2 multiplied by 0.1 plus 1 divided by 2 plus 0.1, which this one will become 1.2, 1 plus 0.2 is 1.2 and this is 2.1. And divided by 3, this is 4, divided by 3, this becomes 7, so 4 by 7, which is equal to 7 into 5, 35, 50, 7 into 7, 59, so this is 0.57. When R equal to 1, it becomes 2 into 1, 2 plus 1, 3 here, and 2 plus 1, 3 here, it will become 1. When R equal to 10, this becomes 20 plus 1, 21, divided by 2 plus 10, 12. 3 into 7, 27, 3 into 4, 12, 1.75. So these are the three ratios of the resistor under different conditions.